Hi, everyone. Thank you for joining us for today's webinar. It is a very exciting topic we'll talk about today. And for everyone looking to do GPS data collection in offline environments, this is one where we'll have a lot of great tips for you. Started with how Laterite maps land boundaries with SurveyCTO and MBTiles. Firstly, let's do some speaker introductions. Our speakers today are from Laterite's Peru office, where this project for the Rainforest Alliance took place. Joining us are Nicole Linares and Ricardo Vargas. Ricardo is a research associate who oversaw the success of this project and has experience with offline data collection, and Nicole is a research analyst who focused on the technical implementation of this project, including data cleaning, data quality checks, and really figuring out how to use MBTiles. And my name is Shirley Sweeney, and I will be your moderator for today. Our agenda for today. We will go through an introduction of Laterite and its mission, and then really get into the meat of the webinar to show you how the team used MBTiles really effectively to help them collect GPS data offline. We'll also get into a demonstration of the workflow and the steps within their processes, ending with a Q&A. And with that, I will kick it off to Ricardo to start.
Thank you, Shirley. Hello, everyone, and thank you for joining us today. It's a pleasure to be part of this SurveyCTO webinar series. My name is Ricardo, and I am representing Laterite. For those who don't know our work, Laterite specializes in research for social impact. Our philosophy is that high-quality research must be both technically rigorous and also deeply embedded in the local context. Our approach is structured and data-intensive. We utilize advanced quantitative and also qualitative methods to generate evidence that is actually relevant to the communities where we work. We have more than 15 years of experience working mainly in East Africa, and since last year, we're operating in Latin America. Just an example of the work that we do, I want to share a specific case study that brings us to today's topic. Laterite was recently tasked with supporting the Rainforest Alliance work in the San Martin region of the Peruvian Amazon. The objective was to provide a comprehensive data foundation to support their work. This wasn't just a standard survey, it required quite high-quality precision geospatial data in one of the most logistically challenged environments of Peru, the Amazon rainforest. The primary challenge we faced was offline data collection. In the Amazon, connectivity is rare, yet the data requirements were complex. We need to capture three types of data. One was a socioeconomic data survey, also land cover classification, identifying three types on the field. And finally, the type of data that is relevant for today's webinar. We were also tasked with collecting found boundaries. We need to collect polygons of the agricultural plots of the farmers. Crucially, we need to have a data quality system to reduce the potential errors of the numerators when collecting these polygons. Since the logistic costs are quite high in this context, we need to reduce the necessity to do a double or a triple check on the plots. This challenge led us to use a specific feature within SurveyCTO, that is the use of offline layers. We realized that by integrating directly these layers into the survey forms, we could increase the accuracy of the numerators and also validate the found boundaries at the moment we were collecting the data. To explain exactly how we achieve this, Nicole is going to do a demonstration where we will include what MBTiles are, how to generate them, how to upload them into the forms, and finally, how to do some real-time quality checks in the field. So yeah, basically, Nicole, you can go with the...
Thank you, Ricardo. Let me start by explaining what MBTiles actually are, because this is the foundation for everything we will do later. MBTiles is a specific file format designed to store maps efficiently. Instead of saving one large image, MBTiles file contains a tile set, a collection of many small image tiles that together form the full map. This structure allows maps to load much faster, even on devices with limited processing power. And why does this matter in field work? Because MBTiles can be downloaded and stored locally on the device. That means enumerator can access high resolution satellite imagery or custom maps without needing an internet connection. And this is extremely useful in rural areas or in places with unstable signal. Another advantage is that MBTiles keeps the map lightweight. Even though the map may look like a large, detailed satellite image, it is actually built from hundreds or thousands of small tiles that display only what the user needs at each zoom level. This makes navigation smoother and quicker. In the image on the right, as you can see, there's an example of an exported MBTile using a high-res satellite base map. This is a type of offline base map that enumerators will have available directly inside SurveyCTO. And later in the demonstration, I will show you how this looks on the tablet and how SurveyCTO automatically reads the MBTiles layer when you draw a polygon. But for now on, I think the key idea is that MBTiles give you fast, high-quality offline maps that work seamlessly inside your forms.
And a quick question before we move on, Nicole. So it sounds like MBTiles are a great resource for you to grab visual depictions of your map in offline settings, and which sound essential for this type of farm boundary confirmation you were doing for the Rainforest Alliance. And I'm curious if there were other alternatives you looked at before settling on MBTiles, or, if you didn't manage to use MBTiles, what would the alternative course you would have had to take?
Yes, thank you, Charlie. Well, basically, we chose MBTiles because it's a format that SurveyCTO can support in their forms. It's easy to put it in the tablet. So basically, it's a format that allows us to make customized maps and also put it on the tablet. So, yeah. And about the alternatives, I don't think there are too much of alternatives. Like, there's two ways to do that. First, we can choose an online map, but you need internet connection. And the other option, if you don't have internet connection, is MBTiles. So basically that. Before we jump into the live demonstration, here's a quick overview of the full workflow we follow to generate MBTiles and how to use them on the tablet. The workflow is basically a 5-step process. First, we load the satellite layer in QGIS. Then we generate the MBTiles using raster tools. Third, we upload the file to the tablet. Fourth, we configure the offline map in SurveyCTO Collect. And finally, we use it to draw polygons and check data accuracy. I will walk you through each of these steps in detail in the demonstration, but this slide gives you like the big picture of how everything connects.
And I'm curious, Nicole or Ricardo, if you can also talk through how you worked with other stakeholders in this project. So you mentioned the technical workflow involving MBTiles, but I'm curious how your experience working with the farmers were, between the farmers and enumerators, because I assume once you load the MBTiles, the maps onto the tablets, you would also be working with the farmers to have them confirm their farm boundaries.
Yeah, definitely. During the demonstration, maybe we can talk a little about how was the experience also for the farmers. We're going to focus more on the numerators, but we can also talk about how it went with the farmers on the field.
Yeah, let's start with the workflow explanation. So we start by opening QGIS. I have QGIS already open in my computer. And some introduction about what is QGIS. QGIS is an open source geographic information system used for spatial analysis, mapping, and geodata processing. QGIS allows to visualize multiple geospatial layers, edit both vector and raster data, and generate offline maps like MBTiles. While QGIS is not the only software capable of producing MBTiles, it is the tool we selected for this project due to its flexibility and our team's familiarity with its workflow. So once QGIS is open, we need to load the satellite imagery we are going to use as our base map. For that, I'm going to use the Quick Map Services plugin in QGIS and search for my base map. For this project, we use Google Satellite Hybrid because it includes both a high-resolution imagery and refers features such as roads, place names, and administrative boundaries. Yeah, it's loading. So now we have our base map, and what we are going to do next is import the Peruvian district we are focusing on. For this project, we are going to import Moyobamba district in Peru. So yeah, now we have our base map and our district in QGIS. And this is important because a clearly defined district boundary is essential when we are going to clip the imagery to the area of interest, because it helps reduce processing time and prevents the creation of unnecessarily large MBTiles files. So now that we have this, we are going to go to step number 2, that is generating MBTiles in QGIS. To do that, we will go to Raster Tools in the toolbox and generate XYZ tiles. With Ricardo, we play a lot with these features. We figure some features that we can recommend you, but this can change depending on your own project. First, we have the extent. The extent defines the geographic area for which QGIS will generate the tiles. When you select a district polygon, QGIS clips the map exactly to that boundary. So this reduces the size of the MBTiles file and avoids generating unnecessary tiles outside the area of interest. So I will choose Moyobamba. An important thing prior to do that is uncheck Moyobamba. Otherwise, it's going to appear in the MBTiles layer, so we don't want that. And then we are going to focus on the zoom levels. This specifies the zoom levels included in the output MBTiles. For us in the project we worked, zoom level 19 provided a very high level of detail, suitable for identifying parcels, paths, and boundaries during field data collection. Through testing, this zoom level proved sufficient for enumerators to trace plot boundaries with confidence. However, it's important to note that the optimal zoom level may vary depending on the objectives and scale of each project. Depending on your project, if you have smaller parcels or bigger ones, the zoom levels can change. So ideally, we chose 19. But for this demonstration, I will go back to 12 because it takes a little bit of time to generate an MBTiles with zoom level of 19. So only for this demonstration, I will keep 12. Now going to the next one, that is DPI, dots per inch. This represents the physical resolution of the output images. For web maps, including this one, 96 DPI is a standard. So it ensures compatibility with platforms such as SurveyCTO. Higher DPI values do not improve on-screen clarity, but do increase file size unnecessarily. So I will recommend you to keep DPI in 96. Next, we have the anti-aliasing option. We are going to off this because enable anti-aliasing increases processing time and file size. Also, satellite imagery does not benefit from this feature a lot, so we prefer to keep this off. Then we have tile format. This determines the image format used for each map tile. we chose JPG because it's suitable for satellite imagery, maps that do not require transparency, and it helps you to keep file size small. So we don't have a very high MBTile, very large one. And now finally we have the quality. This controls the compression level applied to the JPG tiles. Higher values, better quality, but larger files. Lower values, smaller files, but reduced clarity. Then again, we chose in this case 75 because it gave us a balanced result, enough clarity, but a file size optimized. Finally, we're gonna go to output and save the file. So I will save here in this folder the layer that is called Moyobamba. And Moyobamba 1. Save. We will run this. Okay, so now we have generated the MBTiles. We are ready to put it on the tablet. Here we have. This is the MBTiles that we just generated in the demonstration. And now we're gonna put this onto the tablet. That is the third step. I have already here my tablet. Now that everything is connected, we navigate through its internal storage and we need to follow this path to put the MBTile. So I'm gonna do this quickly, but you can see here the path that I'm gonna go through the demonstration. So Android, data, SurveyCTO Collect, files, configuration, layers, and here we have our layers. So here each map must be stored inside its own folder, and the name of that folder becomes the name of the map visible in SurveyCTO app. I will create a new folder called Moyobamba 1. And I will copy paste my MBTile. So yeah, that's it. That's how we generate the MBTiles and put it on the tablet. Here I have also another folder called Moyobamba Final because I also want to show you how this looks on the tablet. And Moyobamba Final is the MBTile with zoom level of 19. That is the one that I talked to you about. So yeah. So going through some steps, we've already generated the MBTiles. Now we have it on the tablet, and I will show you how this looks on the tablet. This is my tablet screen. I will open SurveyCTO Collect app. I'm gonna change this, just I'm sure. Yeah, now I'm on the main menu, and we're gonna fill the form for this explanation. First, what is the unique farmer's ID? Well, I'm gonna put this one. And then we have, what is the total area of the farm being visited today? I'm gonna say 2 hectares. And then what we are gonna do is start geoshape. And we can see here the map. I'm gonna zoom in to Moyobamba district in Peru. And on the right corner, we can select the offline layer that we've just put into the tablet. I'm gonna choose Moyobamba Final, since it's the one that we have with zoom level of 19. And if we zoom in to Moyobamba, the offline map is gonna be here, as you can see. This is a satellite map that our enumerators are gonna look when they are with the tablet. So now what we are gonna do is to draw the polygon. Let's see. Let's draw the polygon. Now we have our polygon and we will save this. Perfect. And the next part, it gives us the polygon size that we just drew. For example, here we can see enumerator, the size declared by the respondent is 2, while the size of the polygon is 0.44. The difference is greater than 1 hectare. And it is recommended to validate data with the respondent and add comments about the discrepancy. So this is important because it gave us a real-time data quality check. Maybe the polygon was incorrectly drawn, or maybe the farmer doesn't quite know well how to measure their own land in a satellite image. There can be a lot of reasons why this can happen, but if you need to, you can go backwards and draw again. Communication. So this is important because in our experience, sometimes this drawing can be mistakenly done, so they can redraw this again. I don't know, maybe greater, and save this. And yeah, for example, the size declared by the respondent is 2, while the size of the polygon is 1.23. The difference is less than 1 hectare, so the message change. And yeah, looking at the screen, we can see the declared area, the calculated polygon area, and the difference between the two. I'm gonna show you now the XLS form that you can see exactly how the calculation is implemented. So the logic works as follows. First, we have the geoshape, that this is gonna be the polygon. Collect the farm polygon or farm boundaries. And then we have this feature of SurveyCTO that calculates the area of this polygon. This is a built-in function in SurveyCTO that computes the polygon area in square meters. Then the next step is divided by 10,000 to have the value in hectares. And finally, now that we have the value in hectares, we calculate the difference between declared area by the farmer and the polygon area. The declared area and the polygon area. Now that we have the difference, we have the nodes. For example, enumerator, the size declared by the respondent is the declared area, while the size of the polygon is the polygon area. The difference is the next one, no? So it gives you like, if the difference is greater than, when the difference is greater than 1 hectare, it is recommended to validate the data. So here we have the conditionals. If the difference is greater than 1 hectare, or if it's less. So yeah, I'm gonna keep it here. At the end, this node shows the enumerators when the difference is greater than 1 hectare or when it's less. This threshold, we chose this threshold because it was, I don't know, it fitted with our project, but you can choose any threshold. Like, it depends on every project. To wrap up everything, let me briefly summarize the full workflow we just followed. First, we started in QGIS by loading the satellite-based map using Cook Map Services. We generated the file. Second, we exported the clipped satellite imagery as an MBTile and put it onto the tablet. In SurveyCTO, this required creating a folder named as we want the layer to appear. Fourth, we configure the offline layer directly inside SurveyCTO by selecting the folder named map from the layers menu. And finally, we demonstrated how enumerators can draw the polygon, how SurveyCTO calculates the area automatically using the geoshape and area functions. But yeah, together these 5 steps allows enumerators and teams to collect accuracy spatial data in remote, low connectivity environments while maintaining strong data quality controls. Thank you very much, and I think that concludes the demo.